Hello everyone, it's July 31st, the last day of July. Ooh, let's take a look. Nothing here. Well, let's take... Oh! We're doing an old friend. Trapping rainwater. I did it at least 2 times myself before the interview. And we did it in the interview, but it was just a hell of explanation. I can't even explain myself very well, right?
Oh, you solved it?
Yes, like right after the interview, I put whatever we coded into the judge and it passed.
Oh, then why did
Because it's a very convoluted. Like I know what the solution looks like when I'm trying to imitate it, but when I explain it, it just my ability was not there. This is for me, this is a nightmare question because I think I did it twice before that, and neither time I was able to do it. Even after the first time, I already knew the solution. The second time, I couldn't do it. It was very difficult for me. And that interview was the first time I was able to solve it by myself, but very convoluted. Like I kind of remember what the solution is. Like even now, I vaguely remember. I know it's gonna be a stack. It's gonna be a monotonic stack. That's the only thing I know. But other than that, I just once the actual the problem starts to unfold, it can get complicated. But again, we have the same one today. If we're able to figure out in the first shot, then this will be very fast. This is going to be done in 20 minutes. But if I got stuck, it's going to look at it like a 2-hour thing. Yeah, I think this is one of the first hard question that I got seriously stuck. All right, anyway. This was Microsoft, right? Yeah, ridiculous Microsoft interview. 2 hard questions back to back. Unbelievable. But anyway, we don't need a Microsoft anymore. All right, let's take a look. I mean, we don't have to take a look. I know what this question is. I've done so many times. This is the 4th time, if I remember correctly. All right, integers, elevation, each bar is 1, compute how much water can trap. All right, so it is going to be I should say monotonic. It's a stack. I know it's a stack, which is like you have this, and then anything that's below we don't push, right? Anything that's higher than we push into the stack, right? If it's lower, we push. If it's higher, then we pop until we cannot pop no more, and then we can accumulate the amount of water that's trapped between hold on do it again. So we push, right? We push this. If it's lower, then we don't push. If it's higher than the previous, if it's lower, we push. If it's higher, then we're gonna pop. And each time we pop, because we know the distance, right? And every time we pop, I have my current height, right? So we know, oh my God, this is a hard question. I cannot figure out even by thinking about it. All right, so if it's lower, we push, lower, we push. If it's something higher coming in, that means we can hold some water there. And what we're gonna do is we're gonna pop the lower one, and when we pop, what is the amount of water that can be held? Oh, I think it's the total amount, right? It's the total amount minus the barrier, right? So this might be not too obvious, but we have here, this is 0, and 0, 1, 0, and 2 comes in. So when 2 comes in, this 0 will pop. So we're going to minus 0, right? And then this is lower, but I don't have anything. Hold on, this is 0, this is a 1 coming in, then we pop. And at the front is going to be a 0, right? Huh. So it has to be something higher, right? Something higher. So now we have something higher, so we know the amount that we can hold is going to be the distance times the smaller height. No, it's not the distance times the smaller height. It's the distance times the height, the difference between the two heights. I don't know why this question is always hard on me. Like, I understand it every time I look at a solution, but then the next time I need to do it, I don't know. So we have 2 bars, right? And then a third bar is also smaller. Now I have let's say a large giant bar comes in. So I say giant bar comes in, the first one, this one gonna get popped, and I think we're gonna pop everything that's smaller than me. So we make sure that the current left is always the local maximum. Okay. So which means when this comes in, these two will be popped. But how do we calculate the amount of water that we can hold? But we know that the current left is the local max until now. So the leftmost that you can pop, right? You can pop until you cannot, right? So we pop until we find something even higher, right? So if we find something even higher, then the total amount you can hold, we can calculate that. That is the height of the, like if we have something really high here, right? And then when this comes in, we're gonna pop everything, and then we hit something we cannot deal with, then the amount of water is held by, is limited by this, right? Limited by this. So we can say this height times the total distance minus all the heights in between. So that's the amount of water it's held. And that's it, right? And then if we come another one even higher, then we're gonna pop this, and then we're gonna compute all of this. But then this one is like counted twice. How do we figure? Every time it comes, and we can pop. So we keep popping. If we pop, that means those are smaller than me, right? Those are smaller than me. And we go all the way until we cannot pop anymore. So that means either I am in the front, or I have something that's in front of me that's higher than me. So when I pop, we compute the amount that can be taken away, right? The amount that can be taken away in between these two. So the next coming in, and we can compute the amount of water because that's held by the current one, right? And if something comes in with hold on, if something comes in that's higher, and is higher than how much water can it trap? Something comes higher than if something comes in, like if it's like this, all right? So you hold water into here, but if something even higher comes in, right? Then the water hold is this. Hmm. And currently we'll have this and this, right? And then something comes in with even higher than the amount of water we can hold is going to be, so when we pop this, like that's the height, right? So we'll compute the distance between the two. Because we say anything in the stack we already done that can be held by that, right? If that is the goal, right? We in any interval we have found the total amount of water that can be trapped. Like if we know the total amount that can be trapped, so we're trying to go like lower, right? So if we already know the total amount that can be trapped between these two, it doesn't matter. We already know the amount of water that can be trapped between two bars, and we know how much. Then the next one comes in. If it's shorter, then we just add it. Well, we pop everything and then we add it. And then we also know how much water can be trapped between this and this, right? So when something higher comes in, right? When something higher comes in. Now when the higher comes in, so what I first see is a short one, right? If I see a short one, then I know I need to pop it. But what I also know is we need to keep track of the height that I'm popping at. So we trap the height that I know, and then if I find the next one, right, because it's gonna be low to high, so we have this as the lowest. We keep track of the lowest, and then we keep popping. I mean, it's gonna be higher, right? So we go to high, and then we keep pop, that's not right. That's not right. Yeah, but it's gonna take a while. I forgot. I forgot how I solved this. Every single time, like just I know the general idea, but I just can't figure out. And by the time I see the solution, I'll be like, oh, that's so simple. It's ridiculous. This is my nightmare. I have a couple of nightmare questions. This is one of them. I dread it every time. I'm like, please don't be this. Please don't be this. Uh, come again. So we have a bar, and then the next bar only has two scenarios. If the next bar is higher, then the current bar is, so there's going to be no water held between the current bar and the next bar if it's higher. So I just pop the current bar. But if I pop the current bar, I don't know how much water I can hold unless I look to the left. Right? 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 we're getting there. Like when I pop a shorter one, I look to the left. If I am the first bar, then and I don't have anything on the left, then I just pop. There's nothing to be added to the trap water. But if I have something on my left, we're talking about in the stack, right? If I have something on my left, and we are doing a monotonic decreasing stack, so when I get popped, I can always look to the left. If there's something on the left, then there's a difference in height, right? So that difference in height is, well, not necessarily. It depends on the current bar coming in. So the current bar coming in, if I'm shorter, then I just push it in. There's no computation needed. If I am higher than the current end of the stack, or I can say top of the stack, then I need to compare the next one, right? The one to the left and the new one. If the one on the left is shorter than the one on the right, then I compute the difference, and we can compute how much water can be held, like extra, right, in between. In between, just when I pop my current one, we know how much water can be held. Yeah, how much water extra can be held in between these two. Okay. When we add it, then we pop the next one. Okay, that's when the left is smaller than the current one. What if the left is larger than the current one? If that's the case, then when I'm coming in, I then compute the difference between the current at the end of the stack and the newly added one, right? We compute the difference, and then that's the amount of water we can hold. And then we pop. We're gonna pop the shorter one no matter what, right? We're gonna pop it. So no matter what, if something larger comes in, the short one is gonna be gone, right? So when the short one is gonna be gone, we just need to compute the amount of water that can be held above the short one, right? The amount of water that can be held above the shorter one, and now that amount of water can be levered by the ones in the stack or by the new ones. It could be both situations. So we make a comparison and then we add that amount of water in, and when that is done, we decide whether to push the new one, because the idea is every time you push, right? So everything in between, every time you push a new bar, everything between the two bars inside the stack has already been computed, right? This is our guarantee that everything is computed. So we only need to compute the extra, like on top. All right, let's use this idea and to see if we can handle this situation. So we have a 0, right? And then we have a 1. 1 is larger than 0, right? So for the 0, we need to look to the left, and the 0 is the first one, so no water can be held. So 0 gets popped, and nothing gets added to the result. Now 1 is the first one. Now 0 comes in. We don't do anything because 0 is smaller. Next one is 2, right? This one is 2. So 2 comes in. We'll look at the 0. 0 is smaller than 2, so 0 knows I need to get popped. So 0, right? So now 0 look to the left and 0 to look to the right. So 0 finds out that the left is smaller than the right. So I use the left as the boundary. So 1 minus 0 is 1. So the delta distance 1 times the distance. So this and this distance is 1. So 0, 1, 2, 3. All right, it's going to be 3 minus 1 minus 1. Right? So the distance is 1. So 1 plus 1 equals 1. So this one gets 1 water, and then 0 gets popped. Now look at 1. Look at 1. 1 say, okay, I need to look to my left. And 1 doesn't have a left, so 1 gets popped. Now 2 is at the front. 1 comes in, nothing. 0 comes in, Nothing. 1 comes in. 1 is larger than 0, so 0 look to the left. Left is a 1, which is equal to here. So let's say if it's equal, we still use the left, and the distance is 1. And the difference in height is 1, distance is 1, so we're going to plus 1, right? So we're going to 1 plus 1 right now, and 0 gets popped, right? Now 1 look at this is 1. If it's equal, we just pop it. It doesn't matter. If it's equal, yes, if it's equal, that means it's not going to affect, so we're just going to pop it. So equal, we pop it. Now the front is 2. It's larger than me, so I don't do anything. So 1, keep. Next one, 3. 3 comes in. So now we have this one is in place, right? So this one is in place. I said I'm smaller, so I need to look to my left, which is 2. And 2 and 3, 2 is smaller, so I use 2 and myself, so the difference is 1. And the distance between 2 and 3 is 1 to 3. So it's 3 times 1 is 3, so 1 plus 3, and then 1 gets popped. Now 3 comes in, 2. 2 is at the front, so nothing more to add. 2 gets popped. So now the front is 3. Next, 2 comes in. We don't pop anything. 1 comes in. We don't do anything. 2 comes in, right? 2 comes in. 1 is smaller. Look to the left. These two are the same. We use this, so 2. 2 minus 1 is 1. Distance is 1, so we're going to add 1. And then 1 gets popped. Now it's 2. 2 is the equal to this one. 2 gets popped. And then this is 3. 3 is bigger, so 2 going to be appending. Last one is 1, append, and we end. So the total value is 1 plus 1 plus 3 plus 1. It's going to be 5. Oh, no, 6. We might have it. All right, let's try this one. So we're going to do the same analysis. 4 goes in, 2 goes in, 0 goes in, 3 come in. 3 come in. We're going to do difference is 2. 2 times 1, so we have 2. So pop 0. Now we have 2. 2 is still smaller than 3, so look to the left. So we have this is 3, 4, this is 3. So this 2 difference is going to be 1. So 1 times the difference between these two is going to be 2, right? The difference is 2. The distance is 2, so 2 times 1 is 2. Now 2 gets popped, right? And 3 come in, 2 comes in, 5. 5 come in when it pops, pop 2. Pop 2 when you use 3, so height difference is 1. That's going to be plus 1, so 2 gets popped. Now look at 3. 3, 4, and 5, so we go 4. Difference is 1. And the distance is going to be 1, 2, 3, 4. Distance is 4, so plus 4. And then 3 gets popped. And then 4 is smaller than 5, but nothing is 4. 4 gets popped. Answer is 2 plus 2 plus 1 plus 4 is 9. I think we got it. I think we got it. Well, don't celebrate too early. I just run the 2 test case, and then it seems to be working. Imagine you're in an interview, right? And then the interviewer is listening to me babbling like this. The interviewer is going to get frustrated. Like, I don't understand anything this guy is saying. So, all right, this is what we're going to do. So we have a stack, right? And then we're going to say res is 0 for h in height. Actually, it's fine. We can say, we actually can put the stack. We can put something inside the stack. No, I'll just say if not stack or stack minus 1, I'm going to push a tuple in. So we're going to go height and I. So we're going to have the index as well. I have to enumerate it. So we're going to push let's push index and height, right? So when you say if stack's empty or stack 1 is bigger than me, right? Is bigger than me, then we let's say stack dot append IH, right? It's bigger than me, then I append. Else, there's a stack and stack is smaller or equal to me, right? The smaller or equal to me. Well, if it's smaller or equal to me, actually we can say if it's equal to me, then I just don't do it. I can just say elif stack, like we escape this equal to. Now we don't do the equal to. Is smaller than me. I'm gonna consider smaller than me. Equal to me, it just can fall through. We don't care. So now it's smaller. It's smaller than me. Then what we do? Then we say there are two scenarios, right? We say, oh, it won't be two scenarios actually, because if I put some dummy value here, no, I don't like that. I don't like that. I do not like that. So how do I know I am at the front? The length of the stack. The length of the stack is how I know I'm at the front. So the current front of the stack is smaller than h. If length stack is 1, that means front of the stack is the only one. Then we just say stack dot pop and stack dot append. I actually feel like stack dot append is going to be, so actually stack dot append, yeah, we're going to append this no matter what, right? So I think we can put this at the end. It's like a global, and we don't even handle this, right? We just say if stack, and stack is smaller than me. Let's say if it's this, else, right? Else, we say we're gonna compare to the front of the stack. So when we say diff, right? Diff gonna equal to the minimum between stack minus 2 and h, the minimum of these two minus stack dot pop. So we're gonna pop it, right? So minus 2 and h, so that's the difference. And then rest gonna plus equal to, it's not minus 2, it's gonna be minus 2, 1, right? And rest gonna plus equal to diff times I minus stack, because I already popped, so it's gonna be minus 1, 0, and minus 1, right? Rest equal to this. And we actually gonna have to be while. It's not if. It's while stack, and this is smaller. If length stack equal to 1, and then stack dot pop, and this one gonna become false, it'll come here. If it's not, then when the pop here, we do it going back and then check again, and return rest. Now we can do a little bit cheeky, so put that in one line. Okay, so check the solution. So first test case, oh, that's a long array. We have to copy here, 6, right? Second test case, 4, 2, 0, 3, 2, 5 is 9. Some cosmetics. Okay, now it's height, trap, height, run it, unsupported, int and tuple. How? Where? Where we have indent tuple? It says here. Oh, 导 pop. Yeah, that should be 1. What? They both pass. Alright, let's try it. Submit. Pending. Accepted. Alright, we did it. And this is the right solution because only 12 lines. 12 lines of code. If it's 12 lines of code, that means it's good. Alright, so I think this, actually let's double check, see how many times we've done this. If we check the submission history, there's going to be a lot. Number 42, yeah. It's LeetCode number 42. I think this is one of the classics because I kept seeing on my notification, people are commenting on this question. First time to do this is, look at this. First time we did it is, oh, actually, I thought I did it 4 times. Actually, not 4, is it 4 times? First time is 2018, November 29th. All right, look how many times I tried. Starting from 3:14 p.m. and the first time I got it is 6:40. So that's 3 hours. 3 hours and 40 something minutes. And I probably checked the answer. And then, yeah, back then I was trying different languages. Yeah, no, I'm not doing those anymore. So it's 29th. I was like, okay, I've spent the entire afternoon from 3 to 7. And after that, and then the next day, I was like, okay, let's do this in Java and C++. So I did it. So that's the first round I did. Now this is December. Oh wait,
No, next day.
No, this is the first day.
It's 3 days.
That's the next day. That's the next day. Oh my god, I was relentless back then. I was relentless.
Wow, exactly almost 2 years.
Almost 2 years, yeah. That was the interview. This was the interview. Right, this is the interview. This is right after the interview. I tried it and actually it didn't work the first time. I have to change it. Let's see. If I remember right, the solution I came up with interview was quite convoluted. Not like this. This is like very simple, very straightforward. Yeah. I mean, okay, it's the same. And then I say append. Well, this is actually not necessary. And I'll pop while this and this equals. I remember we're trying to explain to the interviewer what pre-pre means. We have a pre and a pre-pre, and that's very confusing. We do need to have pre-pre, but here it's just a pre-pre. We do a -2, that's pre-pre, and -1, that's a pre. So it's cleaner. And also we use a diff, which I don't think we did it here. Yeah, that's a diff. But you know what? This is not right. This is hard to explain. It's very complicated and have an extra check here. I don't even know what this one is doing. No, don't look at this. Look at this is going to pollute my mind. My mind is clear right now. So yeah, this is basically the third try. And the first try took 3 days. Right? The second try, we actually did it. And the third try. Wow, I did 3 days on the same question. Man. Yeah, no need to look at the solution. I think the solution is just brute force n squared. Probably in timeout. I don't know. I think it's go 2 directions, right? Minimum of maximum height of bars on both sides minus its own height. From left to right, left max and the right max, iterate from the current element to the beginning of the array, updating left max. So we gonna keep what's the brute force again? Initialize left max is 0, right max is 0. Iterate from the current element to the beginning of array and updating left max. So we find the left max and iterate from the current element to the end of the array, updating right max. So we find the left max and the right max, and the minimum of the left max and the right max minus the height that's the amount of water that can be added, right? That's the amount of water that can be added at this current position. The current position is actually possible, it's a 0, yeah. So at each one, we look at the maximum to the left and maximum to the right, and then the difference between the two and here is going to give us the amount of water we can add looking at my current height. Okay, yeah, that's understandable. Dynamic programming. Find the maximum height of bar from the left end up to index I in the array left max. Find the maximum height of the bar from the right end up to an index I in the right array and iterate over height. Very smart, very smart. We just go two ways, two rounds. We have the left max and right max at each position. Okay, at each position, what is the left max? What is the right max? And then we go through. Yep, that's ON. Very nice. Using stack. That's the one that we're doing right now. While this minimum height minus top plus distance. Yeah. 2 pointers. Oh, you can use 2 pointers for this as well. No, I don't want to read more, but I do want to check this one again. 2 pointers. I like the stack. The stack, I've used stack to solve this problem, at least on my own, without checking solution for once, right? Twice. I think today is twice. So I solve it twice, right? So if I can memorize this, then we just use this. We don't have to think about any other solutions. How do we explain this, right? We say, we know, like we have a current height. The next height, if it's higher than my current height, then let's say the current height is at the beginning, right? This is a simpler situation. And then the next height is higher. Then we say, oh, there's no water. We cannot hold anything, so we pop it, right? So this way we can guarantee, by doing this, we can guarantee the left bound of the stack will be the local max. And then if I have something lower comes in, we cannot hold any water. We don't know, so we just pushing in. And we can only start holding water when some height comes in, which is higher than the top of the stack right now. Now, this is where magic happens. So we need to pop this, right? But every time we pop, we need to compute the amount of water that can be held by the top of the stack and the height to the left of the top of the stack. So like the second position on the stack. Now to compute between the second position on the stack and the new height coming in, we need to compute the distance, like the height difference between the one to be popped and either the ones on the stack or the new one. So we pick the lower of the two, So now we compute the amount of height difference, and then we also need to compute the distance difference between the second of the stack and the new height. And then we can compute the amount of water that can be held, right, above the height that's going to be popped. And then after we popped, we push in. After that, we pop it out, and then we continue doing this, and then boom, we got it. All right, let's see this one. From the figure, is that as long as right max is larger than left max, the water trap depends on the left max. And similar is the case, yes. So we can say that if there is a larger bar at one end, we're assured that the water trapped will be dependent on height of bar in current direction from left to right. As soon as we find a bar at the other end is smaller, we start iterating in the opposite direction. We must maintain left max and right max during the iteration, but now we can do it in one iteration using 2 pointers, switching between the two. While left is smaller than right, if height left is smaller than height right, if left height is larger than equal to, so we get a left max, also add left max. Okay, why is that? If the left is smaller than right, that means at least there's something on the right that's bigger than the left, right? So it's going to be dependent on the left. Yeah. Because we look into the left, we look into the right, and then the amount of water that can be held is dependent on the smaller height. So if left is smaller than right, we go with the left, right? And if left, so we update the left max, and we're gonna add left max minus height to answer. Why? Is else? I don't think it's else. We check it to update the left max. Because the left max is the maximum on the left so far, right? And then we always need to do left max minus left height. We add this. Going back up, and then we check on the right. Okay? Let's run this. Left is 0, so we're going to do left, which is currently 0. Left right is equal. High left, update right. So if it's equal, we update right. It doesn't matter. I think equal, we can update anything. So now right is bigger, so no, left is smaller. Update left. And then this one left is smaller. So yeah. Now right, update right, but it's still gonna be at 0. And this one is smaller, yeah. 0. Coming here. And this is gonna be 0. Coming here. Updated, Here. Current max. Oh wow. Good solution. I'm gonna try this. Yep. I'm gonna try this. 2-pointer solution. Guys, this is actually the third time. This is the third time I have solved this problem. It's one of the the nightmares for me. And I'm glad that we figured it out. We use a, call it monotonic stack. We keep the heights in the stack in decreasing order. If a new height is smaller than the top of the stack, we push it in. We push both its height and index in. Else, we need to pop the stack. But each time we pop, we need to compute the amount of water that can be held above stack minus 1, between stack minus 2, and the current height. This depends on the height difference between stack minus 1 and the smaller of stack minus 2 and the current height. Once we obtain the height difference, we can compute the amount of water by multiplying the height difference. The height difference. Oh, sorry. But you can actually use it, add some flavor to your food.
I'm gonna add sugar and pasta.
That's from the chicken.
Oh.
No, it's not brown. It's the chicken. The brownie is still in there.
On the brownie.
Alright, we can get some saltiness on the brownie. Like the caramel, you know, we have the salt on the sea salt on caramel. That's fine. We compute the amount of water by multiplying the height difference and the distance. Right. The distance between stack minus 2 and the current height using their indices. That's it. ON solution. Actually, don't know. What's the runtime this time I got? Same thing, 56. Too many people have solved this. Too many. Way too many. It's a popular question. Pop up once in a while. Not very often. These guys gets highlighted again. 3 lines plus 1. I have 1-liner? Oh my god. Yeah, I think it's just accumulate max, that's the left. This is accumulate the right. And H. So we have 3 things. Yep. 1-liner. Good. Very good. Alright. So let's try. I like the 2 pointers. I want to try the 2 pointers. This is the 2 pointers solution from the official solution. So as usual, we need to come here and I think the most vote is not them. Yeah, it's Pachman. Pachman is not the first though. These are 2014. Wow, 2014. I was young back then. What a wonderful solution. I would never get a job. Oh man. All right. Never mind. No. Let's do most of votes. That's fine. Most of votes. Hop is the current idea, right? This one is the current idea. All right. So 2 pointers. We keep track, right? So the idea is that for any height, right? Given any height, we want to compute how much water this height, how much water can be held above the current height. And this is determined by the max height on the left, to the left of the current height, and the max height to the right of the current height. By the min, by the smaller of the max height, blah blah blah, and if we use 2 pointers, one at the start and the other at the end. Bless you. If height low is smaller than height high, that means for the current height in consideration, we must use the left max for computation. Otherwise, we use the right max. So we switch between the left and the right depending on we must use the left max for computation of the amount of water held above the current height. Otherwise, we use the right max. So basically, we switch between the left and right pointers to compute the amount of water held above each height until the 2 pointers meet in the middle. Right, so low high equals to 0 and land height minus 1, while low is smaller than high. Is it smaller or smaller equal to? It's a good question. Well, every time we hold, yeah, it's the smaller term, right? We say if height low is smaller than height high, right? That means we will be looking at low for computation. And we say we also need a left max, so L max and R max, both going to be 0 and 0, right? So if left is smaller than right, that means for low, if we're looking at low, then the amount of water that can be held by above low is going to be determined by the left max, not the right max, right? Because the right max would definitely be higher than the left max, because the height on the right is larger than height on the left. So we say if this is smaller, then if height low is larger than left max, right? Then when update, maybe we can just do this. Left max equals max height low and left max, and we'll have a res plus equal to left max minus height low. That's how I understand it, right? So we just always get the left max and then we minus the current. And low plus equal to 1. So we consider it, we move on to the next one. Else, basically it's the exact same thing, but it's going to be right max equals to height high, right max high, and it's R max, and be high minus equal to 1. Right. Once we're done, we're going to return res. Alright, let's take a look. See, solution 2 works. Right, looks good. So let's submit this. And if it passed, then we're going to call it a day. Submit, pending. Yep, that's good. Alright, that's it. So we had another try on this problem. Pretty good. I will see you guys tomorrow for another difficult one. Adios.